Alright, so here we've got to calculate the area of the square tiles. And if we draw a little diagram of the square tile that's 1 by 1, remember that area is length times width for a rectangle, but this is a special case where the sides are equal. So the formula for area is side squared. So for the first one, if we sub in for 1 squared is 1. And 2 squared is 4. 3 squared is 9. 4 squared, 4 times 4 is 16. And 5 squared is equal to 25. So those are the values we're going to use for our graph. So the next question, where it says, describe what happens to the area of each tile when the side length of the tile is increased by 1 centimeter. Well, what happens is the area increases, but it doesn't increase by a constant number. We're going to come back to that in just a second. So when the side length is increased by 1 centimeter, the area increases, but not by a constant amount. So the amount keeps changing. Now the next question, you're asked to construct a graph of area, and you have to decide first of all what is the independent variable and what is the dependent variable. Well, you got to ask yourself, does side length depend on area, or does the area depend on the side length? And the answer to that then is area depends on side length. So that means area is the dependent variable and side length is the independent variable. So side length is independent and area is the dependent variable. So that means when we graph this, and so we're going to title this area of a square, area of the tile. And we've got to go from, put our side length down here. And our side length is going to be in centimeters. And we've got to go from 0 to 5 because that's the values we're given. So we're going to go up by, every other one is 1, so we're going up by halves. And we've got to go from 0 up to 25. So we can go up by two and a halves. So every other one is 5. And this is our area. And that's in centimeters squared. All right, so when we plot our points, the first point is going to be 1 and 1. So this every line going up is 2.5. So it's going to be pretty close to 0. So this is approximately 1 and 1. 2 and 4. So 4 will just be below the 5. 3 and 9. So that'll be just below 10. 4 and 16, which will be just above 15. And 5 and 25, which will be right there. And what we have to do now is draw a line through those points. Hey, I'm getting good at that. Anyway, so moving on then, the next is we've got to figure out what the relationship is, what describe the shape of the graph. Now the graph is nonlinear, so that's the answer we're looking for there. So the graph is nonlinear, so that's the answer to D. Next question is we have to calculate the first differences, and so as we go from 1 to 4, our first difference is we're going up 3, so it's positive 3. Going from 4 to 9, that's an increase of 5. Going from 9 to 16, that's an increase of 7. And going from 16 to 25, that's an increase of 9. So there's our first differences. And what do we notice about the first differences? And they are not constant. And you want some answer that includes that. Make sure you write your answers on all assignments in full sentence form, but basically I'd want you to mention that they are not constant as far as the first difference values. Key here is that the first differences are all different. And this is the relationship we're starting to see, is that when first differences are constant, then it's a linear relationship. And when, as in this case, where first differences are changing, it's a nonlinear relationship.